Right, so in today's lesson we're going to learn about modulus functions. So very broadly speaking, the modulus, otherwise or alternatively known as the absolute value of a number, is the magnitude of the number without the sign. Okay, that's the broad definition. And as I said, modulus and absolute value are interchangeable. So modulus function could also be absolute value functions. Right? They are the same thing. So before we get into the definitions of a modulus, the notation that we use to indicate modulus are two vertical parallel lines, and usually we'll have some number or something in between. Okay, that's the indication of the modulus, absolute value. So we're going to look at three definitions for what absolute value is. Right? And they get more complex as we move along. So the simplest definition, we can call this definition 1. The absolute value of the number, quite simply, is the positive value of a number. That is the simplest definition of absolute value or modulus. So, some examples. If we want the modulus or absolute value of 5, we're not interested in the positive or negative, we're just interested in the positive value of the number, and we can see that that's just going to be 5. We could say, what is the modulus of negative 3? And the modulus of negative 3 is just 3. We're not interested in the negative sign. So we're just interested in the positive value of the number. Okay. Now, if we had some equation using modulus, so say we had 3 take away the modulus of negative 1, what would that be equal to? Well, the first thing we need to do is consider what is the modulus of negative 1. Well, the modulus of negative 1 is just 1. So we would have 3 take away 1, and that's just equal to 2. Right? So this would not be 3 take away negative 1, because we're not interested in the negative solution. Okay, definition number 2. So, what is the modulus of a, for instance? Okay, and we can just say that the modulus of a is the square root of a squared. So, what do we mean by that? Well, if we consider that the modulus of a number is always the positive value, by squaring the number first, we, by nature of squaring, make it into a positive number. So let's again take our example of the modulus of negative 3. Okay, this is equal to the square root of negative 3 squared, which is just the square root of 9, which is 3, right? Now, we haven't said positive and negative square root. The square root sign, by definition, implies that we're only interested in the positive solution. If we wanted both, we would have to specify. Right, let's take the final definition. So this will be definition number 3. Okay, and definition number 3 says the modulus of, let's take x, right, is equal to, and now we're going to open up a parentheses, right, and create a piecemeal function. So we're going to have multiple scenarios for x depending on what its value is. So let's say if x is greater than or equal to 0, right? So if, in other words, if x was a positive number, then the absolute value of x is just x. But if x was less than 0, right? So in other words, if x was a negative number, right? How do we make a negative number positive, well, we slap a minus sign in front of it. So it would be minus x. Now, when we are actually given values, real numbers to work with, then absolute value is quite simple. We can look at the number and we can immediately see what the absolute value of the number is. If we are given a variable, like x for instance, we have to consider both scenarios. Because it's an unknown, we have to consider that the number could either be positive or negative. So sometimes, or just like when you're working with quadratics where when you take the square root, you have to consider both the positive and negative solutions. With absolute value, you have to consider all the different scenarios. And these scenarios are what we call cases. Okay, the negative case or the positive case. Right, now we can expand slightly on this absolute value. And we can say, well, what if it's not just x? What if we have some other stuff in the bracket with x? We could have, for instance, ax plus b. What is the absolute value of ax plus b? So again, we need to consider all the cases, right? And we could say, well, if ax plus b is greater than or equal to 0, well, then it's just ax plus b. And if ax plus b is less than 0, then it's the negative of whatever ax plus b is, which just becomes minus ax minus b. Right, let's look at some simple examples to get us going. Okay, we're asked to solve the absolute value of 2x plus 1 equal to 5. And so the first thing we need to do is consider what values of x the modulus function would be positive or negative. So we'll look at this separately. And we can say, well, what if 2x plus 1 was greater than or equal to 0? Well, if 2x plus 1 was greater than or equal to 0, it would be positive. And so the positive solution would just be 2x plus 1, right? Because remember, the absolute value is just the positive value out of it. And if we continue solving this inequality, we can see that this will happen when x is greater than or equal to minus a half. Okay, and that's quite important. So x needs to be greater than or equal to minus 1 half for 2x plus 1 to be positive. If it was less than that, you could see there would end up being a negative value. And in the same sense, we could say that when 2x plus 1 was less than 0, right? In other words, if it was negative, right? Then if 2x plus 1 is negative, in order to make it positive, I just slap a minus sign in front of it, and it will become positive. And again, if we solve this inequality, we can see that this will be when x is less than minus a half. Now that's important because when we get our different solutions, we need to look that they also are within the values of x for each case. So let's consider the two different cases. Let's consider case 1. Okay, case 1, we'll consider the case where we say, okay, 2x plus 1 is positive, and it's equal to 5. And we'll just solve for x. So we can see x is going to be equal to 2. Now, what we need to do is check our solution, x equal to 2. We need to check that it's within the restriction or within the range that we're allowed for this positive solution. So when 2x plus 1 is positive, x needs to be greater than minus 1 half. And x equal to 2 is greater than, and so this is a valid solution. And now we can consider case 2. This will be the negative case. So if 2x plus 1 was negative, we would need to make it positive. And in order to do that, we'd put a minus sign into it. And this is still equal to 5. So we'll divide through by the negative. We'll get 2x plus 1 equal to minus 5. And we can solve for x equal to minus 3. So once again, we need to go and say, well, we took the negative case this time, and for the negative case, x had to be less than negative 1/2. And fortunately, x equal to negative 3 is less than negative 1/2, and so both these solutions are valid. And so to round off, we could say the solutions x equal to 2 or x equal to minus 3. Okay, let's look at the next one. So we have the absolute value of 4x minus 3 equal to x. So once again, we need to consider the absolute value of 4x minus 3, and we need to consider the two possibilities that might present itself. So when 4x minus 3 is greater than or equal to 0, then it would be positive, and so we can just consider it as 4x minus 3. Okay, and this happens if we continue solving the inequality when x is greater than or equal to 3 over 4. And again, we can say, well, what if 4x minus 3 was less than 0? In other words, if it was negative, well, if it was negative, we would need to make it positive. And so to do that, we'd put a minus sign in front of it, because a minus and a minus become a positive. And this would happen when x is less than 3 over 4. Okay? So we need to consider our solutions fall within those domain ranges to be valid. So let's do case 1. Okay. Again, I'll start with if it's a positive case. So let's say 4x minus 3 is positive. Solving for x, we'll get 3x equal to 3 and x equal to 1. So I've considered the positive case. My answer is 1, and I need to see if that falls within the domain range. So when it's the positive case, x needs to be greater than 3/4. My solution is, and so it's valid. Let's take case number 2. This is the negative case. So if it's the negative case, I want to make it positive. To do that, I slap a minus sign in front of it. And I'll divide through by the minus sign. And now I will just solve for x. So we'll get 5x equal to 3, x equal to 3 over 5. Now, I was considering the negative case. When it's the negative case, we need our solution to be less than 3/4. So 3/4 is 0.75 and 3/5 is 0.6, and 0.6 is less than 0.75, and so my solution is valid. And so once again, I can just round off and say solutions x equal to 1 or x equal to 0.6. So we have the absolute value of x squared minus 10 equal to 6. And as before, let's consider our absolute value first. Let's consider the two cases that we could get. Okay, well, we could say, well, if x squared minus 10 is greater than or equal to 0, well, that means it's positive, and so the positive outcome is just x squared minus 10. Now, Unfortunately, this is now a quadratic inequality. So if you know how to solve quadratic inequalities, you can continue and you can find the domain in which x exists being positive. If you don't, then there is another way that we can check our solutions to make sure that they are valid. Right? So, like I said, if you know how to solve quadratic inequalities, do that. Otherwise, I'll show a different method. All right, let's say, well, when x squared minus 10 is less than 0, then in order to make it positive, I need to put a minus sign in front of it. So I have my two possibilities, and now let's do our two different cases. So case 1 is where I'm considering x squared minus 10 to be positive. That's going to give me x squared equal to 16 and x equal to plus or minus 4. Okay, I don't have a domain restriction to look at because I'm just going to pretend I don't know how to solve quadratic inequalities. So how do I check my solutions? Well, the simple answer is we put our solutions into the equation and check that they work. So both our values for x, whether they are positive or negative, they're both going to be squared. And when we square both of them, they are going to give us the same answer. So whether you square 4 or you square negative 4, you're always going to get 16. 16 minus 10 equal to 6. 16 minus 10 is equal to 6, and so both our solutions are positive, or correct. Right, let's look at case number 2. This is the negative outcome. We would need to make it positive by putting a minus sign in front of it. I'll divide through by the minus sign. X squared equal to 4. Therefore, x is equal to plus or minus 2. Now, once again, because I'm taking a positive or negative number and squaring it, the outcome is always going to be the same. So I'm going to take my solution, put it into the equation, and see what happens. So I took the negative case, so we're going to go negative, and whether I put negative 2 or positive 2 in there, if I square it, it's always going to give me 4. Minus 10 equal to 6. So we're going to get minus 6 equal to 6, which is 6 equal to 6. And so both my solutions are positive. And so we can say our solutions, and usually you would list your solutions in ascending order, so from smallest to biggest. So x can be equal to negative 4, negative 2, positive 2, positive 4. Let's do the last one. Here we have the modulus of x minus 3 equal to 2x. So once again, I'm going to start off by considering what my absolute values can be. Okay, so when x minus 3 is greater than or equal to 0, right, that means when x minus 3 is positive, well, then if it's positive, it remains x minus 3. And solving this inequality, that happens when x is greater than or equal to 3. So we need a value of x greater than 3 for this to be positive. And you can see if the value of x was less than 3, it would be negative, and obviously if it was negative, we would need to consider it as the negative solution. But that's exactly what we're going to do in the next step. We're going to say, well, when x minus 3 is less than 0, x must be less than 3. And if x is less than 3, we're going to get a negative value, and in order to make it positive, we have to put a minus sign in front of it. Let's consider both our cases. So let's do the positive one first. Let's say x minus 3 is positive. Solving for x, we're going to get x equal to negative 3. So we considered the positive case. Here's the positive case. For the positive case to be valid, x needs to be greater than or equal to 3. My solution is -3, and -3 is definitely not greater than +3, and so this solution is not valid. So now we have the negative case, x minus 3 equal to 2x. I'll divide through by the minus sign. I'll bring this across, equal to 3, so x is equal to 1. Now, this was the negative case. So when we consider the negative case, we see that x must be less than 3. 1 is less than 3, so this solution is valid. And so my only solution here is x equal to 1. Now when we do graphs of modulus functions next, we'll have a visual understanding of why this happened, why we only got one valid solution. But for now, we can use our restrictions on all that help us identify if solutions are valid or not.